Welcome to Cheap Controls. We make videos on things that we struggled with, hoping to help you so you don't. Consider subscribing and hitting that bell.
This is the third video in this twfile command. In this one, I'm going to expand the size of the file, and I'm going to use some random variables so we get different file lengths. I'm going to use the random command that's in the Arduino, so it's not perfectly random, but it'll give us different values, and that's what we're really looking for. In the Nextion, the only thing I'm going to change is the baud rate. I'm going to set it to 115,200. And that's because I'm going to be sending so much more data up to the display that I want to make sure it doesn't time out. The other thing I'm going to change is this B3 button. I'm going to change the background color default and the when it's pressed color. And I'm going to reverse those. And then that way I can show when it's ready to be clicked, or if it's transferring data, I'll have it be a yellow color. And that's 65504. And if it goes into the reset state, I'm going to have it be a red color. I'm going to control all that from the Arduino and the states that it goes through as it transfers the file. We have this flowchart set up to show what happens when we send multiple packets. And we start up with the send twfile command, and that has the total length in the command of the file that we're sending. And then the response is either going to be a 06, which means the file name isn't valid. And in that case, you should probably stop and figure out what it is, not try and resend it. You might want to try and resend it, I don't know, but usually if I've got a bad file name, there's something wrong with the code. The other error you can get is a 1A, which means it didn't recognize the command, or it treated it as a variable. In that case, you could resend the command again. If we get a FE, then we know that the file is set up and it's ready for the first packet. Then we're going to send a header with the size of the packet, and then we're going to send the data. After we send the data, we'll wait for another response. If we get a timeout, we might want to resend the header. I don't get into that in this video. All I respond to is if I get a 05. If I get a 05, then that means I need to send another packet of data. In other words, it received the packet, everything looks good, but it's waiting for more data. If I get an FD, then I know it's successful and we stop. And in our code, right after we send the twfile command, or right before we send the twfile command, that's where we're going to set that button to yellow. And then at the FD, if we get a successful result, then we'll set it to green. And then we're going to use the timeout to set it to red. I don't know if we'll be able to display that state or not. We'll have to have an error in order for that to happen. Now, if you proceeded with this video series and you want to, you can download the files for 185, because I'm going to pick up right from where that left off. And the first thing we're going to do is we're going to create another file. And we're going to call it file.ino. And you can see it will appear up here in the tab structure now. And in this video, I'm going to change how I do things. Since I'm going to set things up in the file tab or the file.ino, I'm going to delete a few things like this header up here. We're going to take care of that in the INO over in that file. And we're going to get rid of this reset header. And then finally on this page, we have to change the serial to because we have to make it match what's in the Nextion. So we'll set that to 115,200 also. And then we're going to switch over to this file tab. And we're going to start with two functions. We're going to have the send header. In the send header, we're going to declare that every time we run this, that character header, so that way we don't have to worry about changing it or resetting anything. And the last 4 bytes of the header have the packet number and the packet length. And these two have the packet number. So when we get the packet number in, we'll set it up into these 2 bytes. And then the last 2 have the packet length. And then down here, we'll send the packet, but we'll send it both to the serial monitor so we can see it, and we'll send it to the Nextion display. And then to clean it up, we'll have the serial print line. And in the case of the reset, if it does get into a stuck state and we need to reset that portion of it, we're not really resetting the display, but resetting it back to normal operating mode so we can get commands. You have to change these 2 bytes right here to FF. And we're going to do that by calling this reset header up here, and we're going to send those 4 FFs in the send header as the packet number, and then we'll have 0 as the packet length, because that's the only change you have to make to send that command to reset the Nextion out of the communication protocol that it sets up by sending that twfile command. But now that we've added this over here, we'll need to go to the input page and clean it up a little bit. And we're going to take this part here, which matches that header, and just change it with the function. So now it's just send header, packet number, and 5. And the packet number will start with 0 and increment as needed. The thing we're not going to need is we're not going to have to reset that header byte 8 anymore, because it'll be dynamically refreshed every time we call the send header. The other thing I want to clean up quickly is this line 14 here. We don't need this DFD reset. If the DFD is equal to FE, we have to send a header and the code then also, so we can delete this. And all we have to do is that send header. Now for this first example, I'm pretty much just going to duplicate the way we left off. I'm going to send 5 bytes or 10 bytes or 15 bytes. And then this 24 and 26, we commented those out in the last video, so I want to clean this up too. So now I'm just sending the 5 bytes. So down in here where we look for that command of 1 and then the value, we won't be needing this anymore either. This line, we commented it out in the last video. But this is also where we want to set that button to yellow. So if we get a valid command, a 1, then we're going to set that value to yellow until all of the packets have been received. And we'll know if they've been received by getting that FD command. And that takes place right up here. So we've received the FD command and we've set all the variables back. We're going to set that button back to green. The only other thing we have is when we reset it. In the file I/O, we have this reset up here. So if we go to the delay, we can get rid of all of this with just that reset header. Now if we reset the display, we want it to be green, or want it to be red. So we're going to delay 100 milliseconds. I'm not 100% sure if after I reset that header, if I need a little bit of time. So I'm going to wait 100 milliseconds, and then I'm going to set that B3 background color to red. Now I'm going to run this now, and it should pretty much work the same way it did before. If the camera's set up and I press the 1 button, we should see something on the serial monitor. And you can see we got the 5 bytes and the file was received correctly. And if I hit that to call up to the file, and then I get the contents, I get 5 bytes and 1, 2, 3, 4, 5, just like it was working before. And if I hit 2, then I get 2 bytes, and you can see that the packet number goes from 0 to 1, but the bytes stay the same, 5 and 5. And if I hit 3, you could see that 1 changed to yellow for a little bit longer because it's sending 3 bytes, and it seems to work okay. I get the 15 bytes and the 1, 2, 3, 4, 5 3 times. I'm going to set the total packet, that twfile command, to issue a random file length that's going to be a lot larger. I'm going to start over here on the main tab, and I'm going to delete this header. And I'm going to delete the reset header. And we're not going to use this file data anymore. We're going to send it 1 character at a time, and we're also not going to know how many times we're going to send it the send times came from the Nextion. When I hit the button, I'd get a 1, 2, or 3, and it would multiply that 5. So I'd get a 5 bytes, 10 bytes, or 15 bytes. But now we're going to get something completely random. So we're going to just replace both those with one variable called total bytes, and we'll set that when we hit the button on the Nextion. So now in this line, instead of setting the send times to a value, we're going to set the total bytes equal to a random number. Now, if you look at the Arduino random command, it's not really random. If you reset the Arduino, you're going to get the same values, but at least they'll change for our example. Now, we've removed the send times variable, so I have to update this line also and change that to total bytes. But you'll notice I don't need that times 5 anymore because the total bytes is going to be the total bytes, whereas in the past it was a value 1, 2, 3, and we had to convert that to 5, 10, and 15. Now up here in the top, we're using this file data. We're writing 5 bytes, and we're writing this file data character array, but we deleted that, so I need to change that. And now we're just going to write a 1 5 times. We have to do the same thing down here. So I'm going to upload this and I'll show you what we have at this point. And you can see it's flooding the monitor with a lot of commands. And we'll scroll up when it's done. And you can see it generated a twfile command of 1807 bytes. So it's looking for a lot of data, and we're only sending 5 bytes at a time. So that's going to take some time to do it this way. We have our timeout set to go after 5 seconds. So down here at the end, we timed out. I'm not sure what happened down here where it's still sending some packets, but what happened was it timed out before it could receive all the packets. And so this packet number 83 is right there, and the hex of 83 should be 53. And you can see decimal 83 is 53. So we're sending the right data up, it's just that it timed out. So now we have to go back and change our delay. And up here on the first tab, we have it set to 1000. We'll change that to 5. So now we have 25 seconds to send all the data, or it'll time out and reset the display. So now we'll press it again. What's interesting is we had a lockup here. After the 41st packet, something happened and it froze. So you can see it timed out, just like we wanted, and it set the button to red. So now when I press the button again, it should take off. You can see in this case, we transmitted the file correctly. And the length of the file is 1249 bytes. And if we were doing 5 bytes at a time, and we did 249 packets, well, actually we did 250 packets, but we'll do 249 for our math. It's equal to 1245. And since it was actually 250, we sent 1250 packets. Now, initially, I expected to get an error here because I thought that the last packet would have to be the exact number, but it doesn't appear to be. So I sent 1250 packets, and when it got that 1249th, it said file received correctly. This is the reason the video didn't make it out last week, because I thought there was some issue here. So I spent some time playing with it, and it appears you set the value in your twfile command, and then all you have to do is send enough packets to add up to that value. And if you go above and beyond it, that seems to be okay. It just stops. It ignores all the rest of that data. And you'll see it when I hit this display and get the data. It's 1,249 bytes. Now we're going to go back and we're going to make it so it's not 5, so we can get the data out a little bit quicker. So we have to add another variable called packet length, and we're going to make that 1,000. Now we can adjust that later, but we're just initially setting it up to 1,000 bytes. On the input tab, we have these 3 lines that we do here, and we do it down here. So we're going to move these over to the File tab. And we're going to create another function over here. We're going to call that function send packets, and we're just going to complete those 3 things. Now, one of the differences is we won't be using this set5 anymore. Now we'll be sending the packet num and the packet length, and we'll be using those variables to decide how much data that we're sending. So now we have this set5 in this next line too. We have to change that to the packet length. So now every time we run this, depending on the packet length, which right now we have it set to 1,000, it's going to send that 1 1,000 times. But now that we have this function, we have to go back to the input tab and use it. So we'll put it up here. We'll also put it down here. Down here at the bottom where we get the command, and we set our random value to be between 1,000 and 2,000 bytes. If we're sending 1,000 bytes, that's only going to be 2 packets worth to get everything here. So we're going to change this to 7,000. So we're going to send more. The file size is going to be larger. So I'll upload this and I'll run it. The twfile command said I have a file size of 5,807, and we send it, so that should be 6 total packets at 1,000 a packet. So 1, 2, 3, 4, 5, and 6. And now if I press the file information, we should see that file size. And so it received the file, and we're able to read from it. Now, this data isn't going to change. It should be all ones. But that's because we're trying to read a large file, and I think we're getting an error because the size of this window or this text box is only 15 characters. But you can see that the packet number is increasing 0, 1, 2, 3, 4, and 5. But this is staying the same, which is 3E8. But you have to remember that these are backwards. So this is your most significant, and this is your least significant. So puts it in a kind of weird way to read it, but once you get used to it, it's not too bad. So now what I'm going to do is I'm going to make this packet length be a variable or a random variable so that they'll change as we show the data or as we go through these steps. So this number should change. And since we declare the packet length at the very beginning, we can change it. So every time we come into this send packets, we're going to generate a random value between 200 and 700. I just want to keep that smaller than the packet length so that we see it step through. The highest number you can do in a packet length is 4,096. The other thing over here is I'm going to change this line. We have this message to tell us the packet number. I'm going to add it now so it'll show the packet length, because we'll see it in hex in the header file itself. But I want to see the decimal version, a little bit easier to read. So now when I hit the button, you can see that it's smaller because it's between 200 and 700. We want to send 5807. If I hit it again, it'll change. And that's what I'm saying. It's not really random, because in the Arduino, a random number will be the same every time you reboot. The first one would always be 5807. But you can see that the lengths can be whatever, and it still works out pretty well where they exceed the value, and then it says we got the packet, and we can see that by that FD. going to hit it again. It's kind of when we get another error, but it works pretty well. You can hit this thing over and over and over. And I guess the real test would be to add all of these up and see if it's around 49,870. Yeah, 4,987. And my guess is that after the 633, it's a little below it, and then after the 299, it's a little above it. Now, what we went through on this video is we construct this twfile command, and we send it up, and that sets it in a certain state. We wait for this FE, and then once we get that, we send the first packet. And sometimes that can contain all the data you need, and you just don't have to worry about it. But sometimes you're going to want to send different, break it up into sections and send it, especially if you get to like 30 or 40,000 for your file size, because you can only go 4,096. And then after that, you wait for that, either the FD or the 0F. And in this case, we got the 0F. So then we put another packet in, and then this has to represent that 203. That's a little weird, F2. 20F. And I guess we just don't get the 0 in front of the F, because it would be 20F. So sometimes the zeros, the way that it converts it from decimal to hex doesn't always work out. So that's fine. But it seems to work. And so what will happen is this value here will count up 1, 2, 3, 4, 5. And then this is going to display this value in hex, so the size. And then eventually you'll get down to where it's received all the packets. It says, oh, I got the file that you requested in the twfile command, or the size number of packets you requested in the twfile command. I've got all I need. I've written it all. I send out the FD, or the Nextion sends out FD, file received correctly, and we're done. In my next video, which may take me a couple weeks to make, I'm going to do a practical example of this. I'm not sure what I'm going to measure, whether it be temperature or force or something, RPMs. I haven't quite figured that out yet. But I'm going to try to make an example that you could use in the real world.
Well, that's about it for this video. If you like what you saw, consider giving me a thumbs up, and also consider subscribing to the channel. Thanks for watching.